right on into it. So, oh, before I forget, let's take attendance. Sorry. Almost forgot that one. And then it looks like it's just the lecture today. So let's get started with it. Loops and lists. So if you'd like to follow along, please open up your idle program, and I'll eventually make a new file for us to work on. But today we are going to talk about how to do loops in Python finally, so that we can do similar things to what we did in Scratch. We can repeat the same code over and over again, so we don't have to like copy and paste it. Like I was drawing 5 squares or something. I had to copy and paste that code, and it was so ugly. No thank you. So loops are all about coming back around on yourself and rerunning existing code. All right, so that's the goal for the day. Let us get started with it. I think the first thing that I do want to talk about is errors in Python, because I think you've gotten a few already, most likely, making your first programming assignment in Python. Let me talk to you about errors just in general. When things go wrong, your Scratch programs, they didn't really have any errors. Maybe you could have an infinite loop, but it doesn't warn you of that. In Python, you could say the wrong thing in Python, and it will yell at you. So let's talk about the 2 major kinds of errors that you'd see in a Python program. The first kind is when the red text appears. It's called a runtime error, and that is exactly what it means. It's an error that happens when your program is running. So it is some sort of unrecoverable error, like the program has to stop, Python has to give up, and it happens as your program is running, all right? And the program will stop itself, it will end itself after a runtime error occurs. So, for example, division by 0 is a very standard example of a runtime error. That's an undefined answer, so if you try to divide a number by 0 in Python, it just can't continue. It's like, what were you trying to do there? You should have checked for that, maybe with an if statement. So let's see, what lecture? We were at lecture 19. I will make a new file, a new Python program file in a folder that you will eventually have access to. So let's go to the desktop, and we are lecture 19 apparently. There we are. I'll call this runtime error. .py. And so here's my file now. I'll make it tinier. And here's the REPL. I'll put it over here, maybe. There we go. And so here's my file. Let's make a simple example of dividing by 0, one that you couldn't determine ahead of time if your program was gonna divide by 0. So let's ask the user for a number. So like input, enter a number, please, user. And since we're gonna get a number and put it in like a num variable or an n variable, let's make sure to convert it from a string, which is what input gives you, to an actual int. Right? Let's assume they're only going to give us whole numbers, the user. And then let's try to divide 42 by that n, whatever the user typed. So like 42 divided by n is, remember, if you use comma in the print function, it will just space separate a bunch of stuff. And then here I am calculating 42 over n. All right? So this is where an error might occur if the user types a bad number. And obviously, you wouldn't know ahead of time before the program runs if this is going to go wrong or not. It's essentially the user's fault, or maybe the programmer's fault for not checking if the n was 0. Okay? And then I'll just put some extra code down here just to show you that the program will stop when a runtime error occurs. So here's my program. Enter a number, get the number from the user, and then try to divide 42 by that number. And so this will work most of the time, assuming the user types a number that's not 0. So like if I say enter number 2, that puts 2 into n. It's like, all right, 42 over 2 is, well, it's 21.0. Not too bad. And then it, of course, continues with the line after that. So that's no problem. But if I type 0 for that number, it will get saved into n. And that will cause a red, scary error, right? It's saying 0 division error. Division by 0 occurred in your program. It was trying to do it here before it printed something. Like it couldn't print anything at all. It was stuck trying to get all the things first to print. So it didn't call print yet, and it stopped the program because you divided by 0. And so you're not getting to this line, no hello, for example. None of that's working. Any questions about that? That's a runtime error. The program can't continue. Something went so horribly wrong that it is unrecoverable. All right. So that's a runtime error. The next kind is the much more subtle kind. It's called a logic error. You might have heard this before. It's called a bug. So the fancy term for bug is just a logic error. And this is when your program runs to completion. Everything's fine, but instead of the thing that you wanted to happen, something else happened. It's a bug. It didn't work right. But the whole program runs. There's no red or anything. And so here's a silly example of a logic error. Like you make a variable called I, set it to 42, and then you make a variable called I plus 2, right? You can imagine what that should store. And you set it equal to I plus 1, right? So I plus 2 is a variable that's holding 43 when really it should probably be holding 44 given its name, right? So your program is probably going to work fine. No bad things are going to happen. You're just going to get a weird result. It's not right. Does that make sense? That's a logic error. That's a bug. Okay. I'm sure we've had plenty of both of these as we've written Python or even Scratch. Plenty of bugs in our Scratch programs too. Any questions about either of those? So do not be scared of errors. They happen to all of us. Just fix them and be on your way. All right. So if we're all right still, I would like to talk about a new kind of type in Python. It's a type that has little things inside of it. It's like a big type that holds smaller types. It's called a list. This does not exist. This equivalent does not exist in Scratch, so it's a new concept. A list holds a bunch of stuff in a single place, in a single variable, and the order matters. So, for example, let's say that I would like to make a 3D video game, and I want to keep track of the 3D coordinate where the player is right now. So here's my 3D coordinate system, and I don't know, the player is at the coordinates 1, 2, 3 or something. Here's maybe 2, 3, 5. How about that? So 2 on the X, 3 on the Y, boop, boop, boop. And then 5 on the Z, 1, 2, 3, 4, 5. So up here is where the player is somehow. Maybe they're flying in the game or something. And so that's the coordinate 2, 3, 5. And right now inside of a program, we would like to represent that somehow. The only way we know how is to make like 3 separate variables. Make an X variable, set it to 2. Make a Y variable, set it to 3. Make a Z variable, set it to 5. But these are all separate things. And you kind of like coordinates to be all in one place, all together in one big chunk. So that's where lists can come in. You can make a list of a bunch of things at once. You use the angle or the square brackets like this. You just put a bunch of numbers comma separated, and that creates a list of numbers in that order. Okay, so I'd read that as the list 1, 2, 3. That's the syntax. And so instead of making a separate place for all those things, I can just save a point variable equal to the list 2, 3, then 5. And it's like the whole thing. The box that holds P is that entire set of 3 numbers. It's the whole list 2, 3, 5. They're all there at once, all together. See how that's pretty nice to have, just be able to put a bunch of stuff in the same spot. And order in a list is important. Like this is 2, 1, 3, or sorry, this is 1, 2, 3. It's not the same as the list 2, 1, 3. The order matters in a list, and I'll show you how to get pieces out of a list in just a second. But that's what it looks like. And a list is just a single piece of code. It's a single entity as far as Python cares. It's like it all is in one spot. You could put an entire list in one variable and save your point for later. Just all in one spot, rather than using 3 separate variables that you have to worry about keeping all together. Okay, so that is the goal of lists. Let me try and show you some cool things about it. Gosh, how do I want to do this? Yeah, let's make a new file, I guess. I'll call it lists.py. And here I am. Here, let me make a list. P equals 2, 3, 5. So I've just made a list, put it in a variable, and I can, of course, print P. It's the whole thing, right? Here I am running it. I get the 2, 3, 5. Print the type of P. It is going to be of type list. That's the type, and it's got smaller pieces inside. It's got 3 ints inside of it. That's pretty cool. Let's see what else. Just on the REPL here, a list, if you've programmed before, a list is the equivalent of like an array in Python or vector. So you can put whatever you want in a list, like strings, hello, world. That's a list of 2 things. If you have programmed before, this should make you feel very uneasy. 1, hello, 3.14, world. Python doesn't care. You can put whatever kinds of types you want inside of a single list. So that might make a few of us uneasy, but that's a normal thing to do in Python. Just make a list of whatever types you want. The first thing's a 1, the second thing's a hello, it's a string, this thing's a float, and then you got another string after that. It's not a problem. So that's lists in a nutshell. Let me talk to you about how you might want to use a list, because like you got them all these numbers in one place. How do you get pieces out? That's the first idea. And like, how do you make bigger lists? So yeah, the standard way of making a list, if you have all the pieces in front of you, just give all the values that you want in order. So make the list 1, 2, 3. You can also build lists from smaller lists. There's a concept of an empty list. That's just 2 brackets all by itself. And you can like put stuff inside of it if you'd like. You can add 2 lists with a plus. The plus works on lists. So like if you give it 1, 2, and add that to the list 3, 4, that will generate for you the list 1, 2, 3, 4. Let me show you that in the REPL. So if I make the list 1, 2, and add that to 3, 4, that will generate the bigger list 1, 2, 3, 4. So that's one way to add to the end of a list, for example. That's quite nice. The empty list is like the unit of this idea. So like the empty list plus 1, 2 is just going to be the 1, 2. The empty list has nothing in it. Okay. Let's see what else. You probably would care about how many things are in your list, and there's a len function that does that. If you say len of some list, that will give you back the size of it, how many things are inside. So the len of the list 1, 2 would give you back the number 2, because that's how many things are in that list. So for example, if we go back to my lists.py program where I have this 3-element list, I can say print the length of p, and of course that's 3. It's got 3 things in it. Okay. What is the len of the empty list? Of course that is 0. Okay. Any questions about that syntax? A list is just a piece of code that can hold multiple things, as many as you want. You can add them together and have a lot of fun. All right. The final piece of the puzzle is getting stuff out of a list. Like I put all these things, these coordinates inside of my list. How do I get the x out only? How do I get the y out only? How do I change the y to something else? Things like that. And this is called indexing. So lists are accessed, individual pieces of a list are accessed and modified by this process called indexing. So if I have a list called x, and I set that to, I don't know, 5, 6, 7, this is really what's going on inside of Python. It makes the list called x, but I really want to draw it like this. It's got 3 pieces to it, 3 separate places. It's got the 5, it's got the 6, it's got the 7, and each of those are directly accessible with indices. And they start at 0 because everything in computer science starts at 0. And so here is the index of the 5. The first thing, it is index 0 in the list. So the first thing's always index 0. It starts at 0. So if you want the next thing, the second thing on the list, it's really index 1. And index 2 is for the 7. And so that's how it goes. Every list, the first thing is index 0. And then you can use those same angle brackets that you can use the same square brackets that you use to make the list to get stuff out of it. You can be like, hey, give me that list x, but only give me the 0th index of it. This is the syntax that you use. You say x, brackets, and the index you want out of it, and that will give you back. It will go there and give you back the 5, for example. That's the thing at index 0 in this list. And so, like, you could say, hey, what's x of 2? What's x at index 2? That's the 7. That's fine. And that's the syntax. Okay? You could also go backwards. This is a thing that's special for Python. If you want the last index, you could calculate it using len. That's possible. Be like the len minus 1 or something. But an easier way to get the last index of any list is to just say -1. So instead of 2 as the index of the last list, you could also have said, give me x of -1, please. So you have options with Python. -1 is a valid index, so that means the one before that would be -2 and then -3. So you could work this way. Indices can be negative and they go backwards if you do it that way. So every place in a list has two separate indices, one that's non-negative and one that's negative. All right. So that's that idea. So if I asked for, hey, what is x of -1? That's another way to get me the 7. What is x of -2? That's the second to last element in the list. That'll give me the 6. I could have also gotten that by saying x of 1, x at index 1. Any questions about that syntax? A little weird looking, but hopefully that makes sense. And you can also change stuff with that same syntax. So like, all right, print, what's p of 0? That'll be the 2, right? Print p of 2, that'll give me the 5. That's this index 2. Goes 0, 1, 2. Print p of -2. That's the second to last thing. That'll give me the 3. So I should see 2 for the 0, 2, then 5. That's the last element, index 2. Then finally, -2 is 3, because this is -1. This one's going to be -2. And so the same syntax works for setting pieces of the list. So I can change p of 0. I can give it a new value. P of 0, please have 7 inside of you now. So you can use the same syntax to change an index. All right. And so now if I print p out all over again, it's not 2, 3, 5 anymore because I changed index 0 to be 7. Now it's 7, 3, 5. That's pretty powerful. You can change just a piece of it and get out every individual piece as well. Any questions about that? Those are your lists. Those are their indices starting at 0 or -1. And now I have a question for you. So please go to the written ice page. I'll have you write this down for fun. And I'll clear it out for us. Whee. There it goes. So here's my question for you. Here's a list L. It's got these numbers in it. Please write down 2 different ways to get the 5 out of this list. So like, how do you get the 5 out? What are 2 different ways to do it? It's like print some expression that prints the 5 using the list, and then print some different expression that gets the 5 out of that same list. Okay. Any questions about the question? You'll have to figure out indices and all that. There might be a fancier way to do it too. So give that a try, and then I'll take a look at what you write. I'll give you like 2 minutes to think about it. Please help your neighbors. All right, a few more seconds, then I'll take a look. If you can't think of 2, just give me the 1. Alright, let's take a look and see what we're thinking. Or are we just not sure? Oh, nice. One group. Thank you. Yeah, there's two different indices there. But please yell at me if you're confused about any of this. I really want to make sure it's clear in your mind. It's very important to me as a teacher, of course. Or maybe we're just a little out of it today. Too many midterms or something. So yeah, those are the two indices, so thank you, the one group who responded. But yeah, there are two ways of thinking about L. You could start the indices at zeros and go from left to right. This would be 0, 1, 2. So that makes this one index 3, 4, 5, 6. So that's one way to get it out. L of 3, that would give me the 5. Alternatively, I could go backwards. This is negative 1. This is negative 2. This is negative 3. Negative 4 would be that one. Negative 5, negative 6, negative 7. So that's the alternate index for the 5. It is at the negative 4 index. That's the fourth from the end index. So yeah, those are going to be our two right answers. Are there any questions about that? Does that make sense now at least? All right. So let's talk about loops now. We're ready. I did want to give us lists first because that gives us something to loop through. But yeah, remember what loops do. They repeat code. Like you got some code, then some more code, and we want to come back around and run that code some more, all over and over again. And so the way that we made a loop, it was like repeat n times in Scratch, or like forever do something, or repeat until. So there was a loop with a condition that was all pointy and stuff like that. This, and then it ran all the code in here, that was its body. This will be translated into Python very similarly to how we translated if statements from Scratch to Python. It's going to be like you say some loopy word, then you give a condition, and then you give a colon, and then you start indenting. And you give the body all the things that you want to do as the loop is executing, all the things that go inside. So you just keep indenting for the body of that loop. So that's what it's going to look like. And let me show them to you. So just like in Scratch, a loop repeats something, repeats a piece of code, and you can control how much repetition happens. All right. The most common loop in Python is called a while loop. So the while loop takes some condition and it executes its body as long as that condition is true. So this is like what it looks like in like a flowchart form. So if you write this thing called a while loop, which I'll show you in just a second, it first tests its condition, whatever is at the top of the loop. Condition. That's your pointy thing from Scratch. Maybe I'll draw that as a pointy thing, I guess. And then as long as it's true, it runs all the lines of the body. As long as that condition is true, it's going to run every line of the body of your loop, whatever you put in the indented part. Many lines potentially. And then it always comes back and checks the condition again because maybe it's still true. And as long as it's true, we want to keep looping forever and ever. Okay? But the second it's false, then it's done with the loop. The second the condition becomes false, the loop is finished. And we have the rest of our code. Rest of your code goes here. Okay? So that's going to be the setup for a loop. And let me show you the syntax now. Right? It's a while loop. There's another kind of loop that I'll show you later. But the first one is called a while loop. So it looks very similar to an if statement. It's just that the body can be repeated now. So here's how you make a while loop in Python. You say the word while, and then you put your condition, the thing that can become true or false, just like you put it there for an if statement or an elif. And then you put a colon and you tab over, as you do. Idle does it for you, right? You tab over, and then you put as many lines as you need. That is your body. That's the thing that gets repeated. This is the body, we say, of the while loop. Okay. That is the goal. That's what a while loop looks like. And I think the easiest one to show you maybe is an infinite loop. Gosh. How do I want to do this? Yeah, so I think the easiest loop to make right now, to show you first, is the forever loop. What's the equivalent of a forever loop in Python? Well, you just say, well, your condition should always be true forever and ever. What's the easiest way to make a condition always true? You just make that word your condition. You just say while true is true, and true will always be true. I hope that makes enough sense. So if you say while true, everything in the body always gets executed forever. Always gets executed. And that will run until the end of time. And so I'll show you what to do if you have an infinite loop and how to stop the program if it was an accidental infinite loop. But here's the idea. Very nice. So, let's make a forever loop. That'll be a fun example, I think. New file. So here is a simple forever loop. You just say while, and then your condition goes here. Put a colon, and then the body of all the things you want to have happen. Let's just make one line for the body. Hello, world. And then, what is a condition that is always true? It's just the word true. True is always true, right? It is supposed to be like that. And then I'll put a statement after that loop finishes, but it will never finish. So this is a line that will never get run because I'm unindenting, right? We will never get here, right? Because this is always going to check its condition and run its body as long as it's true, but the condition is always going to be true. So it's just going to keep printing hello world until the end of time. The loop will never stop, and so we'll never get to this line. This line down here. Right? So let's watch it run. Oh, I have to save it somewhere. I'll call it forever loop.py. And let me run it now. There it goes. All the hello worlds. Infinitely many of them. And so when you have a loop that goes on forever, maybe it was accidental, or maybe you're just done with it now, you can just press the X if you'd like, but the easier way to stay inside of Python is to type Control-C. That stops your program. So just remember that. If you ever run away in a loop in Python, Control-C is the thing that's going to stop you. All right? Control-C stops your runaway program. Okay? That's a fun little example. So this was always going to print hello world because the condition is always true. It will never get to this line. Any questions about this example? Okay, so let me show you some fancier loops now. Let's do some iteration. So going through something, because loops iterate through stuff, right? So let's make a program that prints the numbers from 1 to 10 in order. And before we knew about loops, we'd have to do it like this, right? We'd have to say print 1, then print 2, then print 3, and that is disgusting, and we never want to do that, okay? The way to do this, the way to make this work, is to make a variable, let's call that I or something, and we want to repeatedly print out whatever I is and make it bigger. So here's the idea. Here's kind of the setup for making a program that prints from 1 to 10. So repeatedly, we want to print I, starting it at 1, of course. So that'll print my 1, and then increment I. You see how this is going to print from 1 to 10, or at least until we stop it. Increment I. And so then they'll make it 2, and then it'll keep coming back here again. Now it's, what is I now? Print that, it'll print the 2. Then it'll increment I to 3. Come back repeatedly, print the 3, because I is now 3. Make it 4. So do you see how this is going to get from all the way to what we want? And we want this to stop eventually, right? So we want it to get to 10. Print the 10, increment I one last time, right? Make it 11. But that's where we want to stop. Right there. Right here is where we want to stop, because we don't want to come back and print 11. We just wanted to print up to 10. So our condition for our loop is we want to print as long. We want to print our I value as long as it is less than or equal to 10. Only then do we want to execute our body. Right? That's the goal. So let me show that to you. So this idea, repeatedly, print I, increment I, but stop it once it gets greater than 10. So only continue the loop as long as I is less than or equal to 10. That will be our condition. Okay? So let's do that. New file, I'll call it loops.py. Let's see if I can put everything I want in one spot. There we go. So I'm going to start a variable I at 1, and then as long as I is less than or equal to 10, and of course it is right now, let's print whatever I is, and then also increment I equals I plus 1. Okay, that's the increment I part. And so this is going to do exactly what we wanted. It's going to print from 1 to 10. I hope you see why. First, hey, is 1 less than or equal to 10? Sure, print it. Make it 2. Is 2 less than or equal to 10? Sure, print it. Make it 3. Is 3 less than or equal to 10? Yes, of course. Print that. Now make it 4. And so it'll do this forever until it gets to 10. Prints our 10. Is 10 less than or equal to 10? Sure. Print 10. Make it 11. I is now 11. Is 11 less than or equal to 10? No. And that stops the loop. All right? So as long as the condition is true, it continues. But eventually it becomes false. Any questions about why this prints from 1 to 10? So very similar to what we did in Scratch, but slightly new syntax. All right. What about reverse? Reverse order. How do we print this in reverse? We would have to, well, we want to print 10 first, right? We want to see 10, then 9, all the way to 1. So we'd have to keep a loop, but like the first value of I would have to be 10. Do you see that? So I would have to start out at 10 if that's the first thing that we print, like repeatedly print I, because that would print the 10 first, and then we want to make it 9 to print next. So how do we make it 9 next? We decrement. You see that? Decrement I now. So make it 9, and that'll print, then repeat all this all over again. Print the I, okay, now it's 9, print the 9, print the 8, make it decrement, repeatedly print the 8, decrement it to 7, and so on and so forth, until it gets to 1. That's the last number we care about, right? And so we're going to print the 1, decrement I one last time, so I is going to become 0. And this is the value that we do not want to print. So we do not want to run our body when I becomes 0, but every other one we want it to work. So we'd like to keep printing as long as, what's our condition? Want to keep printing while I is greater than or equal to 1. Because once it gets smaller than that, smaller than 1, this will become false and stop our loop. Okay, do you see why that's the right condition there? So I can program that for you. There. Let me put some dashes here so that we can see it later. See the difference. And so it's going to be very similar, but the first thing we want to see printed is 10, so that better be what I is. And then we want to print I and decrement it. So I minus 1, and we want to keep doing this as long as I is greater than or equal to 0. So this has got to flip. Greater than or equal to 1, sorry. This has got to flip because I is 10, it's going to be 9 next, it's going to be 8 after that. It's always going to be less than or equal to 10. So this would be an infinite loop right now with this current condition, the one from before. Do you see that? Let me run that and prove that to you. It's like, oh no, it's going forever. It's never going to stop because these negative numbers are, of course, less than or equal to 10. Our stopping condition is when I gets smaller than 1. So as long as it's bigger than or equal to 1, keep going. That will give me the right output. Okay? I see the 10 through 1. Does anyone have any questions about why this code is the correct way to print from 10 to 1? Backwards. Okay. I think for my next example, let's do something slightly more complicated with 2 variables now. Let's sum up all the numbers from 1 to 10. Remember how to do that in Scratch? It was always about, all right, we kept some I variable, some counter variable, and then we kept a sum variable that we started at like 0 because we want to keep adding into it. So this is essentially the print from 1 to 10 game, but instead of printing, we're putting the number, whatever I is right now, into sum, adding it in there. So if I is 1, add that into sum. Now sum is 1. Make I 2. That's the next number I want to add into the sum variable. When I do this, I want I to have a chance at being 1 through 10. Those are the values I want to put into sum. Okay. And then add the 2 in. Now the sum is 3. Now make I 3. That's the next number I want to add. Add in the 3 to sum. Now it's 6. Etc. 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 Until like we get to 10. That's the last number I put in. I added into it, and I think the sum from all the numbers from 1 to 10 is 55, right? And then I increment I one last time. It's 11. I do not want to run my body anymore. Please stop. And then the sum is the right value. So the same iteration that we did from printing from 1 to 10 is going to work again. It's just mess with the sum variable rather than printing this time. Okay? That's going to be our goal. Let's see if I can get this all in one spot. I guess I'll keep my picture there. Oh, shoot. Wrong one. What's it called? Loops. There we go. Here. Let's have another little dividing line. And then, all right, here's what I want to do to sum up all the numbers from 1 to 10. I need to start a sum variable at 0. So I want to keep adding into it. I don't want it to be offsetting anything. And then I want to iterate from 1 to 10. So it's very similar to this loop right here. While I is less than or equal to 10. So for every valid value that I want to put into sum, instead of printing it, I want to add the current value of I into sum. Okay? That's what I would like to do now. And so to do that, I say sum equals whatever it was plus I. And so I add it into sum. And then again, I increment I. So now the first time I add the 1 into sum. Now next time I'll add the 2 into sum as long as I is less than or equal to 10. So 1, 2, 3, 4, all the way to 10. Once I becomes 11, the loop stops. All right? Once I becomes 11, the loop stops. And now we're down here. We can unindent and get to the rest of the code now. So sum, after this loop is finished, it has had a chance of like having 1, 2, 3, all the way to 10 added into it. And so sum now holds the correct sum of 1 plus 2 plus 3 plus all the way to 10. All right? And we can print that out. Print the sum is whatever is in sum. And so it's going to work the way that we thought it would. Hopefully the drawing helps there. So that's why we see the sum is 55. It placed all of those numbers into the sum variable. Kept on adding them. Any questions about that one? Slightly more complicated, but it is something we did in Scratch. Okay. Let's see. For my last example for this file, let me show you how to use lists and loops at the same time. Because usually you have like a list. This is a very common programming pattern. Like you have some list that you want to do something to, and you'd like to visit every element of it. Like go through this entire list, maybe add up every piece, maybe multiply them all together, find the biggest thing, stuff like that. That's a very common thing to do. So let me show you the combination of lists and loops. You can go through, you can iterate through a list with a while loop. Here's how. You'll make an I variable all over again, and I will keep track of your index. That's actually one reason why programmers default to the letter I for their iteration variable. That's the index they want to go to, usually. So I'll just make an iteration variable. It starts at 0, then goes to 1, then goes to 2, 3, then 4. Because those are all the indices that I want to go into in the X list. You see that? That's beautiful. So I just want to make sure that like the first index is always going to be 0 for any list. That's what I want to start my iteration at. Please always go to index 0. And then the last index changes depending on how big the list is. But how can I always find what the last index is? It's always a calculation involving the length of the list. So do you see how the length of this list has 5 things? And so if I just say len of x, this will give me the number 5. The last index is just that minus 1. So this is the magic. This will tell me the last index, and so I'll just set my loop up, start an index variable at 0, and have it go to len of that list minus 1. And then just keep going to the list at index I. So let me kind of show you that. So let's print a list with a while loop. So here's kind of the setup. Like you start your index at 0. That's the first place in the list you want to go to. And then while I is a valid index in the list. So while it's less than or equal to the length of the list, let's call it, I guess my example list is called X, minus 1, as long as that's true about I, it's a valid list, a list index, so we can go there. And so you can say something like this. Please do something with X of I. That's the index I want to go to, whatever I is, please. You see that? Does that make enough sense? So like the first time it'll go to index 0, then it'll go to index 1, as long as I keep incrementing it as you normally do. So that's going to be the syntax. It's not like X of 0, X of 1, not hard-coded, it's X of I, and I gets to change. So this will let us visit every element of that list. And so let's print out a list with a loop. So I'll just make a weird looking list, and we'll go through it all. So let's say I have a list, oh shoot, not this file, excuse me. It was my loops file, there it is. Let's put it up there so you can see it all. So let's make a list, I don't know, after adding another little dividing line. Let's make a list, call it L maybe. Let's make it hold some weird stuff like 5, 6, 7, 8, 9, 1, 13, whatever you want to put there. I would like to visit every element of this list and print it all out in order. So the first index that I want to visit is 0, so that'll be the start of my loop. So 0 is always the first index of every list. But the last index changes depending. So back here, so start I at 0, and then I'm going to do this style of things, but the list is called L instead of X now. So while I is less than or equal to the length of the list that I want to go through minus 1, because that's the last index, because this is a list of size 7. So the length of L is 7, minus 1 is 6, and that's the last index I want to visit, because this is 0, 1, 2, 3, 4, 5. This last one is index 6. Don't go any farther, please. If you go any farther, it's a runtime error. So there's that. And yeah, so there's no, you don't know how long the list is, but you know that len of the list minus 1 is always going to be the last index. It's the last index of any list, of every list, assuming it's called L. Okay, that's the goal there. And then in the loop body, we want to do stuff, right? Do stuff with L of I, and then always remember to increment I so that you go to the next index next. And we're just going to print out every element in order. So print L of I, and then make sure I is the next number after this one. And it will stay valid because of the condition of this loop. So I starts at 0, we print L of 0, which will print the 5. And then we increment I to be 1 now. And 1 is still smaller than len of L minus 1. So we'll print L of 1 now, which will be the 6. Make it 2, so that we print the 7 next. And I think you get the idea. So there it goes. It's printing all the elements of that list in order. And that is why we see this output. All right. Yeah, I think that's what I wanted to say about that example. Are there any questions about this one? Please ask them now. I may ask you to do something like this on the final. All right. So, if we are happy, please yell at me if you're not. I have one last fun example. You know how I drew those random squares last time? I had to duplicate code because we didn't know about loops yet, so I drew like 5 random squares. Let's fix that, and let's draw 50 squares this time of random sizes, and we'll also use random colors. I'll show you that, because now we can make lists, and it'll all be fun. So let me show you all of that. I'll make a new file called randomsquares.py. And I'll need to Let me copy in what we did last time. Let's see. Here's what we did last time. And we'll fix this. So here's me copying 5 times. Draw a random square, please. And so I'll fix this in just a second. But here's going to be our setup, right? We're going to loop. We're going to run our body 50 times of drawing a square. We'll just use an iteration variable like I, started at 1, have it go to 50, and then if it, it'll do the same thing 50 times. That's all. And I will keep track of that. And then we will draw 50 squares of random sizes and locations. And then I'll also show you how to pick a random color. Let's get the 50 squares going first. So this code draws a single random square at a random spot. Pick the starting location, pick the side length, draw the square. So this is the code that I'd like to repeat. I don't want to have to copy and paste it. So let me delete all the rest of me copying and pasting it 5 times. That was useless. Well, it was nice because we didn't know how to use loops yet, but now we know. So let's get rid of all this. So it's just this code right here. Just this code right here. We want to repeat it. So we want to put it inside of a loop. It needs to be indented, right? This needs to be the body, so it will get repeated a bunch of times. So let's make an I start at 1, and then while I is less than or equal to 50, so I will go from 1 to 50, so 50 times total. Run this code, and then make sure that you're keeping track of which square you're drawing, so I equals I plus 1 as usual. Do you see how this will run its body 50 times? All I is being used is counting, how many squares we've drawn so far. So do you see how this is going to run its code 50 times, and that will draw 50 random squares of random sizes and locations? After we enter a color, let's just say that the color is let's just hard code it to I don't know, red or something right now. So this is just going to be 50 random squares that are all colored red. But now we're using loops to do it. So let me show you that. So much stuff in the way. Was it unhappy or did it open somewhere? I just can't see it. There it is. So let me run that again. Sorry. Too many windows going on here. There it goes. So there it is. It's running and it's drawing a bunch of stuff. It's actually kind of slow, but it's picking random spots to draw all its squares, and it's doing this code 50 times. It would take forever. So let's change the speed of the turtle. You can say turtle.speed and give it the string fastest. It's make the turtle a sprinter or something. And that should draw much more quickly now. Yay, that's gonna end sometime in our lifetime. So there it goes, drawing 50 squares of random sizes and random locations. And all we had to do is write the code once and have it repeat itself in a loop. So there is our beautiful abstract art. Are there any questions about that? Does that make sense so far? So I'd like to add to this now, to change the color to be random every time. That'll be extra cool, right? So here is the secret. Here's how you can pick a random color every time. What you can do is you can make a list of color names, right, that you could give to fill color, and go to a random index into that list, pick out whatever color that was there, that will give you a random color. That's the trick. So let me show that to you. So instead of saying fill color red, let's pick a fill color, a new one, every time we're in this loop. So pick a random fill color. And so instead of red, it'll be something. But here's the goal. Let's make a list of all the colors that we want to choose from. So I'll make a list called colors. And it will hold, I don't know, let's just put all the rainbow colors. Red, orange, all the things that we could have given to fill color. And we'll let randomness give one. We'll pick a random one every time. Yellow, green, blue, purple. So you can do this for your next assignment if you'd like to not just hard code a random color. If the user picks green, you can just give them some random color other than green if you'd like. But you can also, of course, hard code it, because I hadn't taught you that yet. But we want to find a random spot in this list, right? Because to get one thing out, I need an index. like go to index 0, go to index 1. What are the valid indices? It's always 0 to the len minus 1. So give me a random index between that range. Random index that's valid for the colors list. It's going to be a random.randint, right? Give me a random integer between 0 and what's the last index? It's going to be the length of the list, len of colors, minus 1. So that'll be my random index, and I believe that is what I want. So if I just go there, if I go to colors at this random index, whatever it was, maybe it was 2, it will go and give me yellow, for example. If the random index was 1, it will go and give me orange. And we'll set the fill color to that random place. Just go into colors at that random index. It'll be different every time, and that will give us random colors. Any questions about that idea? Does that make sense? 3 new lines of code, and it's going to look so pretty. Get this out of the way. So there it goes. I'll rerun it for us because it's different every time. It's always picking a random color, then doing the rest of the code that we did before to pick a random spot for a square and do it all over again. Yay. It's randomly not choosing blue very often, apparently. So isn't that cool? So every time, pick a random color, set the fill color to that, and then go through. Go through the rest of our code to draw a random square. Any questions about this code? It's a good one to study, and definitely change it up. I think it would be fun. Any questions about our additions to what we did last time? All right, so I'll give you all this code, of course. Please play with it, make pretty pictures, and yeah, that's the end of our loops and lists slides for the day. And so no new assignments. You got stuff that's already out. Keep working on it, please. Yeah, the rest of the time is for you to do that and to ask questions.